And hello again to Year 9 and welcome to Lesson 4 on our topic of natural hazards. I hope you're all doing really well. I just want to say some fantastic work coming through from all of you. Really super impressed with what we're doing and some great feedback. So keep it going guys and don't give up on it. So well done. Just a little thing here. It might be what you think of me. Aren't we mean and horrible expecting you to read stuff, write stuff and turn it in when it's due? Loads of you are turning it in. And actually I'm probably preaching to the wrong people here, because if you're watching this it means you're doing the work, so keep it going. Before we get started, I just thought I'd have a look at this, just so I was putting the lesson together. This is on Friday the 1st of May. I thought I'd make a comparison between what we were doing last week and what I want you to do this week. If you look at the top slide, this was last Friday, the number of earthquakes of a magnitude of 2.5 and above in the previous 24 hours. And you could see that most of those earthquakes were appearing very much on the plate boundaries. Okay, you can kind of see them around here. Okay, and there was a total of 49 earthquakes in that 24-hour period. None of them particularly huge. I think one of the biggest ones was around about here in the middle of the Pacific Ocean. So as I was putting this lesson together, I thought let's have a look and see what's happened in the previous 24 hours. And actually it's really interesting because again there's only been a grand total of 48 earthquakes, so there's only one difference. All relatively minor, and again if you look you can see mostly around the Pacific Ocean again on the plate boundaries, and in fact looking there's only one or two like up here in North America and Alaska that really aren't on a plate boundary, but likewise nothing of any great significance. But it shows in 24 hours we can have nearly 50 earthquakes that we know nothing about. So every day these are happening and we just need to understand the fact that most of them are very small. If you recall from last week we were talking about the Richter scale and the Mercalli scale. These are all measured on the Richter scale because they give an accurate measurement, a scientific measurement, and the Mercalli scale would only come into effect if there'd actually been any damage. And the fact these are all small and there's no damage, there'd be nothing really to record on the Mercalli scale. So what are we learning today? Okay, our title today is How do Earthquakes Differ in LICs? So what we're going to learn about is we're going to identify an example of an earthquake in an LIC. We're going to analyse the impacts and responses in relation to the country's wealth and to evaluate the effectiveness of the responses. Now whenever we look at a disaster we tend to break it down into three things, and in fact quite often in geography it's three issues. What's caused the issue? What's the effects or impacts? And how are we going to respond? How are we going to deal with it? And that's what's quite significant for us to understand in geography. So before we get going, let's recap and see what you can remember from prior learning. This is lesson 4 now on our tectonics and our hazards. And we've got a Venn diagram. I've got earthquakes and volcanoes, so I'd like you to spend about 5 minutes just thinking about what we've learnt already, and in your earthquakes, in here, write anything at all that just applies to earthquakes. I'll give you a clue, maybe the fact it's measured on a Richter scale. Here, anything at all about volcanoes, so maybe you have shield and composite volcanoes. And then in this middle section, this is our overlap. So in here, anything that applies to both earthquakes and volcanoes. Maybe think about the plate margins they're on. So put yourself on pause, give yourself about 5 minutes maximum, go back through your notes and try and draw out a Venn diagram. Okay, so hopefully you've got quite a few things there that you can think about in your prior learning. So let's see what today's lesson fits in to the topic of what we're studying. So as you know, we're looking at natural hazards. We've already thought about what makes a natural hazard. So we did different types. If you recall, we looked at geomorphological hazards, we've looked at weather hazards, tectonic hazards, and we then spent a couple of lessons thinking about the structure of the Earth and plate tectonics. So our core, both inner and outer, our mantle and our crust, and the fact that our plates move, or our crust moves, and they're either moving towards one another, away from one another, or side by side, for example, a conservative plate margin. And that movement creates different tectonic events, so earthquakes, volcanoes, tsunamis. What we're going on to today is we're going to look at the causes and effects and responses of seismic events. Now, I've called seismic events here because seismic events are not just earthquakes, they will include things like tsunamis. So over the next few lessons, we will look at those issues. To where else we'll look at, we'll then do something very similar. We'll look at causes, effects and responses of volcanoes. And lastly, we'll think about, okay, we've got all these hazardous areas, so why do people live in there? So we're on at the moment this one here, and that's how it fits into the whole structure. So let's get thinking. I've got this image here of an earthquake in an LIC. Now I've used this term LIC, and I've purposely at this point not asked you what the letters actually stand for. So give yourself a moment, look at those images. First of all, what do you think the letters LIC and HIC mean? Look to see here about your predictions. How will the effects of this particular earthquake differ from an HIC, and think about why. Give yourself a couple of moments, put yourself on pause again. Okay, so LIC, low income country. We used to call them developing countries, less developed, less economically developed. Your parents may have gone to school and been told that they were called third world countries, but basically they're a country with a very low income, just less than a few £1,000s per year per person. And then we have high income countries, which are obviously the reverse, the opposite. They used to be called first world, developed, more economically developed. Lots of different terms for it, but now we talk in geography as high income and low income countries. And I'd hope you'd look at this and start to come up with some ideas of why there's differences. Now in today's lesson, we're going to look specifically at a low income country and an example. And then next week, we'll have a look at a comparison of a high income country. So by the end of the two lessons, you'll be able to see that even though both can have exactly the same disaster, exactly the same magnitude of an earthquake, the actual impacts, the effects, and therefore the responses of how people are going to deal with it are going to both be very, very different. So first of all, we need to locate the example we're going to look at. So we're going to look at a country called Haiti. So if we look at the whole map of the world here, we can see that Haiti is an island, well, as half an island actually. It's a country that's attached, if we look very closely, to the Dominican Republic, all the way over in the Caribbean. And if we zoom in a little bit further here, we can see that the plates that it's on the Caribbean plate that is moving towards the Cocos plate. Now when we describe a location, we use something called clock. We've done this a lot in geography. We want to know the continent. So the continent here is often a little bit tricky because it's between the North America and South America. I think it just sort of fits into the North American continent, but you could put it on the Caribbean plate. Its latitude, tell me if it's north or south of the equator. Which hemisphere is it in? Which oceans and seas? And if you have a look, you should be able to see what ocean it's off. It's off the Atlantic Ocean, what seas are nearby. Compass directions. Now with the compass directions, you don't just say it's north, south. So for example, in your description, you want to include compass directions. Normally, when you're thinking about the countries and cities that it's nearby. So for example, Haiti, you would say, is to the west of the Dominican Republic and southeast of Cuba. Okay, something along those lines. And you could say that in a group of islands south of Florida. Think about the scale, how close For example, it's actually attached to the Dominican Republic. So although it's west of the Dominican Republic, it's actually attached, where it's southeast of Cuba, but it's not actually attached to it. Bit of additional information there when you're writing your description of where it's located is include the plate that it's on. Okay, so what happened? I want you to watch this other YouTube video, and it talks about exactly what happened in the Haiti earthquake. So spend a few minutes watching that, make a few notes on it, because you'll need some of that information to put it into context as to what's happening. I'm really sorry, as with all these videos, when you look at them, because it is real disaster, it's real geography, there are some pretty horrific images. So watch them and just realise exactly what's been going on. So you've watched the video, you've got an idea of what happened in 2010 in Haiti. So in order to now build up a really good case study, remember what I said, we're thinking about causes, effects, stroke impacts and responses. So when we start off, we often want to think about the infamous cause and effect. What caused it? So what? Why is it significant? And the best way of doing this is called a multi-flow thinking map. So in the centre, we would want to think about the main event. So in your notebooks, or whatever it is you're writing this out, put the main event, what happened, Haiti earthquake, January 2010, put the magnitude, 7 point whatever it was on the Richter scale. That's what happened. Think about what actually it was. Down the left hand side, you're going to be thinking about the causes, and then the right hand side, the effects. I'll explain this a bit more. Attached to teams, I've given you a list of all the various facts to do with the Haiti earthquake. So basically the notes I pretty much made from your video, but you can add more if you want to. And what you need to do next is to separate those notes. So it's not just, this multi-flow map here just has what appears to be 3 causes, 3 effects. It's more than that. You've got a list, you've got about 7 pages, I think, of it. It's big writing, so it's not as much as it sounds. And try to put those bullet points and work out, are they a cause? Are they the factor that actually led to that earthquake? Are they the effects that what happened? We are going to talk about secondary effects later on. If you want to start separating them now, you can. But their effects, for example, a primary effect would be that people were killed by falling rubble. A secondary effect of that earthquake is because lots of people ended up in refugee camps, the disease cholera spread very, very quickly, and actually they reckon about 100,000 people died from cholera. So that becomes a secondary effect. What would be ideal is a bit of a challenge where you separate effects into 3 categories. Social, so anything at all to do with people. So if you're talking about how many people were killed, how many were injured, whether their homes were destroyed. Economic, so anything that's going to be to do with costing money, if they lost their jobs or the cost to repair something, how much damage, the fact there were no jobs. And anything environmental, the surroundings, including things like water supplies. What I also want you to think about is I've used this phrase, a large natural disaster. Now, when we think about the causes, we want to think about what caused the earthquake, but also what caused this particular disaster to be such a large scale one. So the causes won't just be the plates moving towards one another, the friction building up, pressure eventually being released with vibrations. The other causes will be linked to do with the fact this is a low income country. So have a look at those causes, anything at all that in the background is telling you about the fact that, they have very low income, very few people are educated, very poor government. All of those factors will actually be leading to cause this disaster to be one of the worst natural disasters in history. So put yourself on pause, look for those factors and now put them into your causes and effects. Okay, we're going to now delve into these effects in a bit more detail. You've got another attachment here. I've set it up as a PDF file that I've attached for you, but it's also on the next slide. And we want to think about primary and secondary effects. Now, I mentioned them in the previous slide, and I said to you, primary is a direct result of the earthquake. Rubble falls on you, hits you on the head, kills you. That's a direct result. Industry, you know, you've got a shop, it's collapsed. That's a primary effect. An indirect result is because there was the earthquake, there is now a further effect, but one that you would, for example, fires. An earthquake itself doesn't cause a fire, but the earthquake will shatter the gas pipes, which then leaks gas, which then means that the falling electric cables have sparks. They will then spark a fire. I mentioned previously as well about diseases such as. So what I'd like you to do is you can colour code this if you wish, or you can draw it into a table. Don't mind which way. There's a whole list of factors here. They're only numbered because if you wanted to, you could number them somewhere, but it's much easier if you can colour code these, where these here are all effects of what happened. But what you've also got to do now is separate them into a primary, a direct impact, a direct effect of that earthquake, or an indirect. This only happened because of the original earthquake. So take a few minutes to do that. Okay, so on this slide you can check whether you've got the previous one right. If you have a look here, we can see a list of primary and secondary effects. So some of these here are quite shocking. We've used the figure 220 deaths for various reasons. That figure actually isn't that, it's actually quite difficult to check and see how accurate it is. There's believed between 200 and 320,000 people actually died. 8 hospitals destroyed. Now think about that. The hospitals are destroyed. That's a primary effect. But then if you actually look, because the fact that they couldn't then be treated, and diseases such as cholera, that becomes a secondary effect. So primary, no hospital. Secondary, well, what happened because people couldn't be treated in hospital? Think as well about the hundreds of thousands of buildings and the 4 bridges. If bridges collapse, nobody can then come and access you. If you look at this particular bullet point here, damage to port meant no aid could get in to help victims. So the ports were damaged, the roads were damaged, primary effect. The fact you couldn't get aid to people because the road and the infrastructure collapsed makes it a secondary effect. Right, so let's think about our third learning objective here. We've looked at causes, we've looked at effects or impacts. Let's look now at the responses. Now, when there's been a disaster, we often see adverts on TV about giving aid or help, not aids. Don't confuse the two, please. We give people aid because it's a way that we can help people. So what I want you to do, spend a few minutes. Imagine there's been this disaster, there's been an earthquake, you've looked, you've watched the video. If you can't find a link to that video, go onto anything on YouTube, find what happened. There's loads of images, there's loads of little video clips as to what happened in Haiti. And imagine that they need help. Just brainstorm as many things as possible of aid that they would need. What forms of help, assistance, resources would you need if there's been this disaster in a very, very low income country? Now you've got that list of aid and we can categorise it now. Imagine we've got 3 things from your list. People given tents to live in. They've lost their homes. Remember, they were a low income country. One of the reasons why it was so bad is because their homes were very, very poorly constructed. If you look at Los Angeles and San Francisco have billions of dollars spent on making sure those buildings are earthquake proof. Those tall skyscrapers are not designed to topple should there be quite a powerful earthquake. In a low-income country, the people have barely put together a normally constructed house, so they're going to topple very easily. So as a result, they're going to need tents to live in. Let's also think that they're going to need new earthquake-proof homes to be built, and they're going to then need training to design and build the earthquake-proof homes. Now, let's think about this logically. You've got an earthquake, you've got a disaster. Some of these you've got to give immediately, and some you can take your time and plan and think about future events. So you've got your immediate, must help you now, and you've got your more long term. This slide here gives you these three ways we could categorise it. We have what's called emergency aid, short term help, disaster bang, give people like first aid kits, temporary shelter, medical supplies, food supplies, fresh drinking water, all of that, emergency aid. Long-term aid, non-emergency help. So we're going to, for example, we're going to build some bridges. We're going to rebuild the roads. Sustainable help, we're going to enable people to support themselves. Now, this here, you may have heard this before. You give a man a fish, you feed him for a day. You teach a man to fish, you feed him for life. Now this applies very much to the type of aid. Emergency aid, you just need that fish, you need that food. Okay, you're not interested in what's going to happen in the future. If you don't have it immediately, you are going to die. Sustainable aid is, we actually know that this is likely to keep happening. So we need to make sure we can try to help people to support themselves so that they're not relying on disaster aid to keep coming in, but also to try to reduce the impacts, the effects. So future earthquakes, it's on a plate boundary, it's likely to have future earthquakes. It's also, I don't know if you're aware, but Haiti is also an area that suffers from another type of natural hazards, which is hurricanes. And hurricane season is actually about to start from about April through to about October. They're more powerful by September, October, but hurricane season. So Haiti, actually not long after it had the 2010 earthquake, actually then had a major hurricane, and so the people there who were still in temporary shelters were then also affected because they didn't have anywhere to live. So you need to be able to protect a country from those sorts of issues. So this sort of example of teaching a man to fish will mean they can feed for life. It means if we can help people to be able to support themselves, they will then be able to have that infrastructure in place so that they're not impacted as greatly in the future. So let's think about how we help the victims of earthquakes. So we've got emergency, long-term and sustainable. Now I've given you a PDF file that has got different types of aid, and let's look at this example here. So charities and governments sent hundreds of thousands of tents for victims to live in, and we've, just as an update here, 519,000 people are still living in tents. So that initially would go under emergency aid. They needed those tents. So what I'd like you to do is look at that sheet of all the different types of aid. It's also on the next slide, and I'd like you to try to put them into case. And if you have a look here, so for some reason the numbers are the wrong way round, but it doesn't matter. 1 to 8, the green ones, are hopefully more straightforward. The numbers 9 and 10 are a bit of a challenge, see if you could work out where they would go, and 11 to 14 are a real challenge. You should be able to work it out, but just have a look and see where you would put them. Okay, so well done folks. What you've got here then is a really good detailed case study of Haiti, of a low income country, and hopefully what you've understood from this is that a country like Haiti, any low income country, can have a disaster that's of the same magnitude earthquake of a richer country, but because of some of its political reasons, you know, I don't know if you picked up on the fact that their sort of equivalent of houses of parliament were collapsed, and quite a few politicians were actually seriously injured or killed, which then made it even harder to actually deal with anything. It wasn't the most well, it was a fairly corrupt government in the first place. The fact that people already had hardly any money meant that rebuilding anything was very difficult, and they had to rely on aid, which was hard to get to because the ports were closed, the roads weren't built, etc. So all of these things made a disaster worse because it was a low-income country. So just a plenary, see if you can come up with a word or a sentence beginning with each letter from Haiti to try to summarise what happened in the lesson. And a bit of a challenge, see if you can try and include at least one cause, one effect or impact, and one response. Feel free to send those to me, it'd be really interesting to see what you've come up with. Which reminds me, last week I sent you a challenge at the end of it, which was, could you tell me if 7 is 10 times greater than 6, how many times greater than 5 is it? Well, the answer is 100, because on a logarithmic scale for magnitude of earthquakes for Richter, each number is a multiple of 10 more than the previous one, which means you've got 10 lots of 10. So it's not 20 times more powerful, it's 100 times more powerful. And that's why an earthquake 6 will appear to maybe have a few walls may fall down, where 7, which is 10 times greater, like in Haiti, was horrendous. You know, over 250,000 people died. We had an earthquake just over 5, oh gosh, about 10 years ago, and the greatest damage was, I think, somebody's chimney pot fell down. So that was 100 times less powerful than the one in Haiti. Okay, so now you've finished, you've got the end of lesson quiz. As always, the link will be on Teams and also on ePraise, but it's here as well. Some fabulous scores coming in. Remember what I've said, if you're not happy with your score, feel free to redo it. Okay, take care folks, and see you next week.